class. Today we are starting our chapter all about circles. This first section has quite a bit of vocabulary, but hopefully some of it's review, so it's not too bad. Make sure you get all of these words written down so that when we're using them you have something to reference back to. So you need to actually know what a circle is. A circle is not just like a round shape. It is a set of points that are all equal distant from the center point. And then you need to know that the center is just the point in the middle. And if you don't want to write that down, you don't have to. But you do need to know what that center is. In this case, the center point of this circle is C, and that's the way that you name the circles. So all right, this is used to name the circle. So this circle here, I would call it circle C, and just like when we did like triangles or parallelograms and you drew that shape, you're going to draw a circle, but you're going to put that center point in the middle. So you know that it's not like a 0 or an O. So I would name this circle, circle C, and yep, that's it. This next word, radius, the radius is the segment, and the endpoints are, all right, with endpoints, one of them is the center, and one of them is on the circle. So for this picture here, there's actually 3 radii that are drawn in. For example, one of them might be CD. Okay, or you could say CF or even CE. All of those are different radii. The next word, chord, this is probably out of all of this the word you've never heard before, or at least never in this fashion. A chord is a different type of segment with both endpoints on the circle. So an example of this, AB is a chord. And that's a segment, and that is important because later on in this chapter we'll get to something else where it's not just the segment. Then there's one other chord. The other chord in this picture is DE, and that chord is also the diameter. So to define diameter, we could say that it's the chord that goes through the center. So every diameter is a type of chord. Not every chord is the diameter though. So you'll have to be familiar with these terms. This is kind of the way the questions are going to look. They're going to ask you to name the circle. Remember, when you name the circle, you use that center point. So I'm going to draw a circle and put that center point and then label that circle X. A radius, I just have to give one. There's lots of different correct answers for this. I'll say that a radius is XV. A chord, again, there's more than one correct answer for this chord. I usually like to do the chord that's not the diameter if that's an option, but the diameter would also be a chord. And then lastly, the diameter. This is the diameter, that is ZT. And I know somebody's probably thinking, well, I said TZ. It's the same thing. Either way that you write it is fine. So you need to know how the diameter and radius are related to each other. The diameter is 2 times the radius, or you could say the radius is half of the diameter. So looking at this picture, if it says RT, this is the diameter. What is the length of QV, well, that is the radius. So depending on which one you have to go from, I'm just going to take half of 21. So that's going to be 10.5, and I'll throw the units on there, centimeters. Some things that you need to know about pairs of circles. We have two circles are congruent if and only if they have congruent radii. So if this, let's say, is 7 and this one is 7, we could say that those circles are congruent, and that's the way they have that written there. You need to know that all circles, no matter what the size, are going to be similar. So all circles are similar because that scale factor is, like, let's say this is, we'll go with 7 again, and this one is 4. Well, the whole way around it's going to be 7 to 4, making them proportional. That makes all circles similar to each other. And then this next word, these are called concentric circles. So concentric circles are coplanar, and they have the same center. Kind of looks like that target symbol or a bullseye, or if you play darts, all of those would be examples of concentric circles. When you have circles drawn, some different ways that they can intersect. You could have circles intersecting at two places, maybe like this one here, where you have these 2 points of intersection, or it might look kind of like a Venn diagram if you have those like the same size and side by side. You could have two circles intersecting at exactly 1 point. See if I can make this do, there we go. Where they intersect at only 1 point. Or you could even have like the one on the inside of the other one if you want to draw it that way. Or you could have circles not intersect at all. So you might just have like two circles that are like this. Or, you know, like the concentric circles. Or maybe they're not even concentric, you just have one inside of the other. So there's no way for circles to intersect at like 3 exact points or 4 exact points. The only other option, I guess, would be like if you have a circle that's in the same exact spot as another circle with the same center, it would basically just look like one circle though. So they can intersect at 2 points, or 1 point, or 0 points, kind of depending on how the picture is. So for this next example, I'm going to do my best to kind of sketch out what this looks like. It's always kind of tricky because we have these overlapping lines labeling this. Once you get this down though, or if you can, you know, make sure on your picture you're labeling all of it, we're just kind of adding and subtracting these numbers to figure it out. So it says here that the diameter of X is 22. I have here the radius of circle X, so I know that from X to Z, that entire part's going to be 11. The next one says that the diameter of circle Y is 16. Again, you could draw the whole thing in if you want, or you could draw it in a different way, but based on what I have here, this portion is going to be half of 16, so that's going to be 8. And then you know that WZ is 5. So that's just this part here in the middle is 5. So what I want to do is I want to go ahead and tell the entire thing. So notice that I cannot just add up 11, 5, and 8 because we have that overlapping part. I think what I would do is I would find this piece. So I can find that part by taking 11 minus 5, so that's going to be 6. Make sure you don't just take half of it. Sometimes students think they're the same, especially for something like this. They kind of look like they might be the same, but it doesn't have to be drawn to scale. So if this whole thing is 8 and this part is 5, that part there is 3. So if you wanted to find that whole distance across, you could do that. You would just add the 6 and the 5 and the 3 together. So that whole thing would be 14 units. Yes, you could also add like the 11 plus the 3 or the 8 plus the 6 to get that also. So depending on what parts you're missing, you might solve them slightly differently, but just kind of making sure you're labeling it carefully will be the biggest thing here. Okay, and then finishing out the rest of this stuff is all circumference. You have to know the circumference formula. Should be something you've worked on in the past. Circumference, there's two ways that you can write it. Circumference is defined by being pi times the diameter, or since the diameter is twice the radius, this is the way I usually say it, it's 2 times pi times the radius. So those are the same thing there. Either way you do it is fine. If you want to find the circumference of a circle, let's say that I have this is the diameter, and I have labeled here that this is 15 inches. Well, what you're going to do then is you're going to first of all know that this is the diameter, even if like the 15 is written off to the side, because the whole diameter is drawn in. That's just like the way the book is going to cue you. And you're also going to know that it's the diameter because that center point is drawn in there. So I would just use the first formula. The exact answer to this would be 15 times pi inches. Because most students don't like it like that, what you're going to do then is you're going to use that pi button on your calculator. Make sure you know how to find that, and you're going to type that in. So 15 times pi, you should get that that is about 47.1 inches. So if you were to measure, you know, take a string and wrap it around that circle, that would be about 47.1. If you wanted to use this other formula, again, you could. You would just have to find the radius. The radius would be 7.5, and then you could do 2 times pi times 7.5. The exact answer would be 15 pi inches, or again, you could just type it into your calculator and come up with a rounded value. In this example, it says find the diameter and the radius of a circle to the nearest hundredth, so that's 2 after the decimal place. If the circumference is this here. So what I would do is I would write out that formula. The circumference, so the answer is this. I want to solve for the diameter. What I'm going to do is I'm going to divide the circumference by pi. So grab your calculator, take 65.4 divided by pi. You should get the diameter to be about 20.82 when you're rounding to the nearest hundredth. So that would be feet. If you're solving for radius, I know that you could just take half of that diameter, and that would be fine. I want to show you, though, how we can use the formula, because this is kind of a common mistake that kids make. Make sure you have your calculator handy. When you're solving this, you're dividing by 2 pi. Your calculator will do order of operations for you. You want to make sure that you divide by the whole quantity of 2 pi and not just divide the 65.4 by 2 and then end up multiplying that by pi. So go ahead and take a minute and type that into your calculator. Sometimes students like to figure out what 2 pi is first. That's totally fine, but then you have to like write down some decimals. You should get the radius to be about 10.41. And that would be the answer that I'd want when you're rounding to the nearest hundredth. So it will be important for these that you have that decimal place just right. So if you need to like check that on your calculator or let me know how you got to type it into your individual one, I'd love to help you with that. So to finish these up, we need to talk about inscribed and circumscribed. A polygon is said to be inscribed in a circle when all of the vertices lie on the circle. So I could say here that this triangle is inscribed. A circle is circumscribed about a polygon if all of the vertices, or if it contains all the vertices of the polygon. So I would say that the circle is circumscribing this triangle. It's the exact same picture, it's just two different ways to say it. Just mainly for like the sake of the examples, you know what it's talking about depending on which way it says it. So here I have this triangle that's inscribed, or I could say the circle is circumscribing the triangle. All of those points are right on there, and this is the diameter of that circle. I do need you to do one thing. This will be a property we learn later, but I need you to draw in this right angle symbol. That looks like a right angle. It actually is exactly a right angle. So to find the circumference, I need to find the diameter. In order to find the diameter, I need to look to this right triangle. And hopefully you've already guessed it, I got to use Pythagorean theorem. So I'm finding the hypotenuse, so I'm finding C. I'm going to set this up 5 squared plus 12 squared equals x squared. So 25, 44. I'm going to end up taking the square root of 169, or maybe you recognize this is a very common Pythagorean triple. So the diameter is 13. I know we just did all that work and you probably think you're done. Remember, we're trying to find the circumference. So the circumference is pi times the diameter. The exact answer would be 13 times pi. And that's just what you could write out. If you really have the uncontrollable urge to figure out what that is as a decimal, I guess that would be okay. As a decimal, that is about 40.8 if you're rounding to the tenths. There's no units. If you want to write like units or UN, that's fine. If not, that's okay too. So I look forward to helping you guys with this. I will see you later.